Okay, here is our video for simplifying using the distributive property. So we're using the distributive property here. Today, in this lesson, we are just simplifying expressions. So I want you to take a note that says these are not equations. We are not solving for the unknown variable. Okay, if we were, it would look like this. It would be a whole equation with an equal sign. Okay, and we will do that. We just are not doing that all on the same day. So for right now, we are just going to actually simplify the expression. Okay, so in order to see how the distributive property works, I'm going to show you a quick example. So we've got the number 2, and then in parentheses, we can do 3 plus 4. Okay, I'm just using real basic numbers. Now, we know if we have all of our numbers, we can just follow the order of operations, and we would do 3 plus 4, which is 7. Sorry, my pen decided to not work right now. Okay, there we go. Sorry about that. Okay, and then 2 times 7 is 14. Okay, let's copy down that problem again, and we're going to see how the distributive property actually works. Now, the reason we want to use the distributive property is because you can see in each one of these examples, there's an unknown or a variable. Okay, so in the example at the top, 2 parentheses 3 plus 4, we know all the numbers, but we won't always know all the numbers. So it's neat to see how the numbers can actually work together. So 2 times 3, I'm going to distribute this 2 to the inside numbers. So that's what those arrows mean. I'm going to do 2 times 3, and I'm going to do 2 times 4. Okay, these are all positive, so it's going to be positive 6 and positive 8. So all I do is 6 plus 8, which is 14. Okay? So again, this way is quicker, but that's when I know the numbers. This way works for when I don't know all the numbers, like we're going to do below. Okay, so let's look at number 1. We're going to do this left-hand side together. We have this negative 6 on the outside. We're going to do what's called distributing it to the inside terms. We're going to distribute it to the a, and we're going to distribute it to the 8. Okay, so it's negative 6 times positive a, and negative 6 times positive 8. So negative 6 times a is just negative 6a. Since I don't know what the a is, I can just leave it like that. That means multiplying. And negative 6 times 8 is negative 48. So I can leave it like that, and it would say negative 6a minus 48, or I can say negative 6a plus negative 48. And those are actually the same thing. If you think back to the integers when we added and subtracted, those mean the same thing. Remember, there's nothing to solve. We are not solving. It is just simplifying today, just simplifying. Okay, let's try number 3. We're going to go down. Draw your arrows. We're going to take that positive 6 and multiply it by negative 5n. Then we're going to take positive 6 and multiply it by positive 7. So positive 6 times negative 5n, well, that's going to be a negative answer, right, because they're different signs, so it's going to be negative. And then if I have 5n 6 times, that would be 30n. And then 6 times 7 is 42. So since it's positive, I can call that negative 30n plus 42. And we are just leaving that. A lot of kids are going to want to add those together. They're going to want to somehow combine negative 30 and positive 42, but we can't do that because we don't know what the n is. I promise you, this is as much as you can simplify it. Okay, number 5 is a little different because the negative 8 is coming after. So it's okay though, because it's on the outside, I'm still going to distribute it to the negative 3n. So it looks like this, negative 8 times negative 3n. Then I'm also going to distribute it to the negative 4. So then I have a negative 8 times a negative 4. Okay, go ahead and simplify those two on your own. See if you can get this answer and this answer. Okay, did you get positive 24n and positive 32? You're 9 times out of 10, you're going to see this written with the variable first. So we're going to always put the variable term, the 24n, with the positive 32 like this. Again, that's as much as you can simplify it. There's an n term and a number term. In fact, if you start paying attention to that, it's going to help you on the next pages. So if you actually kind of flip forward a little bit, you'll see page 24 looks just like this one, but on pages 25 and 26, you'll see that we're going to do something called combining like terms. And so you're going to hear that again. This is a variable term and this is a number term. So they cannot go together. Do not add those together. Do not say that that is 56. Okay, it is not 56. Okay, go down to number 7. My outside number is 5. I'm going to multiply that by negative 7n. Did you notice how I said negative 7n? That's because we always pay attention to the sign that's in front of the number. So in front of the 7n is a minus sign, in front of the 1 is nothing, so it's positive. So that's why I keep saying, you know, positive or negative based on what it is. So this is 5 times negative 7n, and then we're also going to do 5 times positive 1. Okay, go ahead and multiply those and write it nice and neat as an expression. Okay, did you get negative 35n and positive 5? So you would write negative 35n plus 5. Again, slow down and go back, rewind it if you need to see something again. Okay, try number 9 all by yourself. Unpause it when you're ready. Okay, so we distributed the positive 5 to the inside terms. The inside terms are positive 3m and negative 6. So when I do positive 5 times positive 3m, I get positive 15m. And when I do 5 times negative 6, I get negative 30. So I can write this two ways. The way that you'll probably see it is 15m minus 30. But if you wanted to put a plus sign right there, you can do that as well. They're the same thing. Because the 15m is positive and the 30 is negative. Okay, this is the last one we're going to do on this page. We have 5 parentheses b minus 1. Again, try this one all by yourself. Okay, did you try it? Did you write 5 times b and 5 times negative 1? Remember, we're distributing the outside term. So that would be 5b, and this would be negative 5. So you can just, you know, combine them like this, or you can write 5b minus 5. Either way is correct. Okay, flip to page 24. Go ahead and try 13, 15, and 17. These will be the last ones in the video. Go ahead and try those on your own. Unpause it when you're done, and you can check to see how you did. Okay, if you are listening to me, does that mean that you paused it and you're going to check to see how you did? If not, please pause it again. I want you to try it. You have a pencil. There's nothing wrong with making a mistake. You're not going to know if you can do it, though, if you don't try. You can always, try one and then unpause it and then pause it again. It's up to you. Okay, so negative 4 times negative 8x. That would actually be positive 32x. Then I distribute the negative 4 and the negative 8. Sorry, that got a little smushed, but that would be positive 32. So I can put a plus sign in between them. It's 32x plus 32. On number 15, it's negative 3 times x and negative 3 times negative 5. And this would be negative 3x, and this would be positive 15. So it's just negative 3x plus 15, since it's a positive 15. Okay, so again, you want to always pay very, very special attention to the sign that's in front of the number. Okay, for number 17, you're going to distribute the 5 to the 1 and distribute the 5 to the 2v. Now, I actually want to show you something here because you might have gone in a different order. When you got positive 5 and positive 10v, you might have written 10v plus 5. And that is fine because the 10V has a positive in front of it, and in this one, the 10V is positive. In this one, the 5 is positive and the 5 is positive. So as long as the sign in front of the term stays the same, then it is okay to write it in either order. So I'm going to show you an example of that when one of them is positive and one of them is negative. Okay, this will be the very last example. If I said that already, I apologize. I'm going to do 19 with you, and we're going to write it two ways. So first, we're going to do negative 7 times 5k, and that's negative 35k. Then we're going to distribute the negative 7 to the negative 4, and that's positive 28. Okay, so I can actually write these two, negative 35k and positive 28. I'm actually going to go ahead and highlight those so that you can kind of see the terms that I'm talking about. Okay, so this is positive 28, and this is negative 35k. I can write them in that exact order like this, negative 35k plus 28. That is correct. Let's put a box around that. Or I can put them in a different order. I can do the positive 28 first and the negative 35k next. I'm going to clean those lines up because I don't want that to get real messy. But all I'm doing is I'm taking the positive 28 and writing it first, and then the minus 35k second. That is the same thing because, again, I'm going to pull out some different color highlighters so you can see. The negative 35k is negative in both. And then the positive 28 is positive in both. So as long as the sign in front of the term stays the same, then you can switch the order. And here's why. If you're not sure why, I'm going to give you an example down here using just integers. So you know what negative 8 plus 10 is. Yes? Think about it. Think about it. It is positive 2. Okay, what if I switched them? What if I said that I want the positive 10 to be first, and I want the negative 8 to be second? Okay, so I'm just going to write the positive 10 first, the negative 8 second. What is positive 10 minus 8? It is definitely 2. Okay, so I just want you to kind of see a little visual on that. That it is okay to switch the order as long as the sign in front of the number stays the same. Okay, if it's negative 8 or minus 8 in one of them, it has to be negative 8 or minus 8 in the other. If it's a positive or plus 10, it has to stay positive or plus 10. Okay, that is a wrap on your distributive property video.